when we have 2 over 5 plus 3 over 5, then the first thing we needed to do is we check the denominator. When you add or subtract fractions, unless they have common denominators, we can't do the addition and subtraction, right? So in this case, we check the denominator commonly both of fraction have is 5. So there is no further adjustment that we need to do. So we can go ahead, keep the denominators. It's still denominator 5. Then I can go ahead to add the top. So it's going to be 2 plus 3, and then it's 5 over 5, and then you can leave it, or you can just rewrite as 1, right? Then what's the difference between adding and subtracting? It's just if we have 2 over 5 minus 3 over 5, and then the only difference is we can just still keep the common denominator already given, and it's 2 minus 3, and then it could be negative 1 over 5. So it's same as negative 1 over 5, right? So that was what we could have done it. But the problem is, this is not the only case that we will see. And so as I mentioned, if two fractions, either adding or subtracting, and they don't necessarily have the common denominators already, then we have to adjust, we have to manipulate the denominators, right? So if we have 2 over 7 plus 3 over 5, let's say, then here 7 and 5 are the given denominators. Then we have to come up with least common denominator. Then least common denominators is least common factor. No, least common multiple, right? So we need to know how to find the least common multiple between two numbers. So the least common multiple between 7 and 5, and they don't have any common factors in it, right? Then all we have to do is just 7 times 5, and then it makes 35, right? So then now we know the denominator between 7 and 5 should be 35 in next step. But in order to make each denominator to be the common denominator 35, and what we can do is you multiply the first fraction top and bottom by 5 and 5, and then the second one by 7 and 7. Then the next step is 5 times 2. 5 times 2 will be 10. And then 3 times 7, which is 21. Then 35 is still kept, but the top will be 31 here, right? Then let's make really simple examples with variables, okay? Then if we are supposed to have it's 1 over a squared plus 1 over ab. Then now I recognize each denominators are not already common. So I have to come up with my least common multiple for the common denominator, right? So then now we have to observe what kind of denominators each fraction, each rational expression has. Then let's see. The first one is a squared. Then this is a times a. So now if I prime factoring the first denominator, this is a squared, and then it's just simply a times a. Then the second one is AB. Then if I prime factor the second denominator, and then it's just simply A times B. Then between this, the least common multiple or least common denominator between this is first I need to have both kinds of variables. So now I have A and B, but here we are getting least common multiple of it. So for A, to cover both, we have to go with A with higher exponent. So now I have to have A with the square. But for B, the first denominator doesn't have B, but second one has B. So to cover both, I do have to have B there. So then LCD in this case, it's just the way that you can find the least common multiple between two. Then this is determined as the common denominators, right? So then the common denominators between a squared and an AB will be a squared B. Then here, just like we did manipulation for both fraction earlier, what I need to do for the first rational expression is I have to multiply this one by B over B so that B times a squared makes a squared B, right? Then what do I have to do on the second rational expression here? I have to multiply what? It's only one A there, so I need one more A, so A and A, right? So then the top will be B times 1 is gonna be B. And then 1 times A is gonna be A. Then this is how you add the typical rational expression that given with non-common denominators already. Okay, any questions so far? This might be a little bit confusing at first, but as long as you firmly understand what we do to fractions, addition and subtraction, and it's exactly what we do. So first you have to come up with your LCD first, and then you observe each different denominator separately, and you just recognize the necessary factor that you have to do each one, then it's gonna give you the next step, okay? Are we all good so far? Okay. Okay, that was example number 1. Then let's pick one of the practice problems so that we can do. Okay, so far we haven't talked about subtraction yet. So let me pick example number 2 from the practice problems, and it's gonna be subtraction. Okay, then now. I see one of the subtraction practice problems in 5.4 goes like this: 3y plus 2 over y squared minus 2y plus 1, and it's subtracted by 2y plus 3 and y squared minus 2y plus 1. Okay, then I guess it's up to you. You can factor the denominators first because they are obviously factorable. But for this case, we can go ahead, execute subtraction first. Why? Because the denominators are already the same, right? But we might have to still simplify it afterwards, so it doesn't matter. So then let's go ahead and execute the operation, the subtraction first. So now we verified its common denominators already. So the next step, I will still use the common denominator already given. Then the first numerator is 3y plus 2. But now what you have to be really careful is, since we have this subtraction here, then after that minus sign, it's gonna get affected by the minus sign individually. So here you have to be careful. This minus will make this one negative and 3 negative. So now be careful with minus, it's gonna be negative 2y and minus 3, right? So this is the only difference between the addition and subtraction if they both have the common denominator. Then next step, let's simplify it. And then on next step, 3y, the like terms are this. So 3y take away 2y will be y. And then 2 minus 3 is negative 1. Then now, the denominator is y squared minus 2y plus 1, but we never had a chance to factor it. But then it's a factorable. Then this is factored as what now? Y and y. And then two numbers multiplied to be 1 and added to be negative 2 is only negative 1 and negative 1, right? So then now we can have y minus 1 in parentheses and y minus 1 in parentheses. Okay, then you can recall how we can simplify rational expressions from last week, 2 weeks ago. Then here I can recognize this whole thing with these identical factors on the bottom. So it doesn't matter which one you pick, then let's recognize that, right? So then we can cancel them. So it's gonna be canceling. Then what's left? It's 1 and then y minus 1, right? Okay, here. Now the simplification is done. But still we are supposed to state something else. What should we say it here? We are responsible for one more thing. Who remembers it? We have to say something further after you entirely simplify. What is it? There's one thing that we needed to say. What was it? Anybody? For rational expression, at the end, we needed to state something. It's related to Tesla. What was it? No? Nobody remembers it? The excluded value. We're supposed to say excluded value. I just say Tesla because it's just abbreviated as like EV. It looks like electronic vehicle. Okay, then what's the excluded value here? So denominators were factored is y minus 1, right? So then y cannot be what value? In order to avoid, so y equals 1 is the excluded value, right? So you can just say excluded value y equals 1, or you can simply say, so another way to say it, just y cannot be 1, either way. But in this format that we are learning, it's just more like this way, right? So either or that, okay? So that was it. Okay, then let's take one more problem from 5.5, okay? Okay, which one could be good? Okay, so there's some simple problems that you can practice for what's the least common multiples and so on. Okay, then I will pick this one here. Example 3. And this is one of the practice problem from the 5.5. It goes 5x over x minus 8 and plus 7x over x plus 8. Okay, now let's observe the denominators first. Okay, the first denominator is x minus 8. And second denominator is x plus 8. So they're not the same. And they don't have any common factors. So only way for us to come up with the common denominator here is we multiply them all together. So then least common denominator for this case is x minus 8 times x plus 8. How do we come up with this? It's just like this. When we had the denominators and 7 and 5 earlier, we just go ahead and multiply them because there's no common factor between them. So we didn't really have to worry about the least common multiple, right? So then if that is the case, then now in the next step, then I can say x minus 8 and then x plus 8 there. Then now the first rational expression manipulation will be, now here I have to multiply top and bottom by what? X plus 8, x plus 8. And the second rational expression needed to be multiplied top and bottom by, since x plus 8 is already given, what I need to multiply is x minus 8 and x minus 8. And it's technically all parenthesized here, right? Okay, then now the first numerator is multiplying x plus 8 times 5x, right? And then in the middle, we have addition here. Then the second numerator is 7x multiplying parentheses x minus 8. Then we can do usually, so we distribute this and then we distribute this. The next step, the numerator side will be x times 5x, 5x squared, and 8 times 5x plus 40x, and 7x times x plus 7x squared, 7x times negative 8 and negative 56x. Then denominator is still x minus 8 and x plus 8 here. Then now, like terms together. So 5x squared, 7x squared is like terms, and then it's going to be 12x squared. And 40x, take away 56, makes negative 16x. Then it's over x minus 8 and x plus 8. Should we leave it like this? No, we still try to simplify it, right? So then the denominator side is already completely factored, so it's okay. But we have to look at the top. So now the common factor between 12x squared and 16x, then we can factor 4x out. Then it's going to be 3x inside, so that it's going to make 12x squared. And then it's negative 4 here. Then x minus 8 and x plus 8. And let's examine this. Do we have any common factor from numerator and denominator to be canceled? Not really, right? So then I can leave it like that, but it's not entirely done. What do I have to do here? Still, we're responsible for excluded value. Then in this case, excluded values for this operations is x cannot be 8 or negative 8. And I guess that's it. So when you just take the written test and then this is just okay, but if you are solving any multiple choice and then if you don't see it directly from this factor form, and what you can do is you can rewrite each one to standard form here, and then if you foil this, it's just, if you do it one by one, and then you can get x squared minus 64, but you can also remember the square, the difference of squares. So this is exactly a minus b, a plus b, right? So they could be this. And then we factored it in order to see if there's any common factor from numerator and denominator. But if you don't exactly see the answer choice from a multiple choice, and then you can just go back and then 12x squared minus 16x. And then I guess that is the answer choice given for the one of the problems on 5.5, right? But honestly, if we just took this one as just normally in class and a handwritten, and I always prefer the entirely factored form. So this is my preferable form, because this one benefits us with more like further steps. Okay, any question? Okay, unless you guys have specific questions, and then I will touch upon the one question that you saw in 5.5, and there's rate application problems there. So now, this was the first one. Okay, so this is just directly copied from the practice problem 5.5, and then let's read it. In a long distance delivery truck averages 8 miles per gallon when the truck is full. So with 1 gallon, this truck with some things loaded can go 8 miles. And the miles per gallon, we usually say it's MPG, right? Miles per gallon improves by 20% when it's empty. So then the truck with fully loaded situation, 1 gallon makes the truck goes 8 miles, right? 8 miles. But then if it doesn't have any thing on top, then of course it's more like energy efficient, and then it can go more than 8 miles. But how further? 20%. Then first we need to see how we can find 20% more, like improves by 20%, right? So then originally it could go 8 miles once it uses the 1 gallon. But what's 20%? So 20% means 8 times the original mileage, and then we can multiply by we convert the percentage into the decimal, right? So it's 0.2. Then what's 8 times 0.2? So 1.6. But it's not only 20% of the original, it's increased by 20%. So then originally it was 8 miles, but increased how much? 20% of the original 8 miles. Then it's gonna make 9.6 miles. So then it makes sense. So with 1 gallon, fully loaded, truck can go 8 miles with the 1 gallon. But if it doesn't have any loads up, and it can go 20% further, which makes 9.6 miles further with the same 1 gallon. Okay, so it's more energy like efficient, right? Okay, then which expression represents the amount gasoline used? So then we will use the variable G in terms of the number of miles driven, and they suggested we use M sub F with the truck with full loaded, and M sub E for the truck with no loads, right? Okay, then in order to come up with the rational expressions to solve this model, we need to talk about the rate that we are using here. And then first of all, what we are using is miles per gallon. So miles per gallon. And we usually say it in MPG, right? Okay, then miles per gallon is the rate, right? But here, and focus on what we are finding. What do we find? The gasoline. How many gallons of gasoline? So here, this is simply miles over gallons is the rate. So the rate can be like 8 miles with fully loaded, and or 9.6 miles with the empty truck, right? Then here, what we have to come up with as the model is not the rate, but it's gallons. So I need to rewrite this formula for gallon in front. Then how can I manipulate it here? So the gallon is on the denominator. Then we can just go some steps here. So that the other side is the rate, and then it's rate over 1. And we can see it's cross multiply here. So then cross multiply is the rate times gallons is miles. And we have to come up with the model. Gallon is isolated, right? So then in this case, we can divide both sides by the rate so that I can isolate gallons. So now it's gonna be gallons represented by the letter G is miles on top and then divided by the rate, right? Okay, do you follow my logic so far? So we started from the MPG because this is the main idea of whole situation here. And MPG is nothing but miles over the gallons makes the rate, the energy efficient rate, which is the MPG rate. Then to model the situation, what we're getting is not the rate, the energy efficient rate, but the gallon. So I manipulated from the given formula. I just rewrote the formula with the isolated number of gallons. And then we come up with this model. Gallon can be calculated with whatever the miles it can go with the given rate on the denominators. Okay, so this is the basic model. But here, what we are further given is it has different mileage rate with the truck fully loaded and with truck with empty situation. So then the gallons in total should be include both situations together. Then I can see we have to come up with separate rational expressions to represent both of the situation with fully loaded and empty truck, right? So then the total that leads us to write the total gallon with the G is whatever the miles it can go with fully loaded is represented by M sub F, right? Is over the rate. What is the rate? It can go how many miles per gallon? The rate was 8 here, right? And then the case that, another case that we have to consider is the miles it can go with empty situation. And then what was the rate that truck or the empty situation was 9.6, 9.6 here. Because we calculated based on the context earlier. So then this is the model for this situation. Okay, any question? Okay, if not, and I'm moving on. Then with this model, the next related question is asking the same situation, so we can use these models, right? And if the truck travels 160 miles full to deliver its goods, and then once it delivers and then it coming back 160 miles empty, right? Because that's gonna be the situation. Then with this, and we can calculate the gallons with this model here. It's gonna be gallons will be how many miles it go with fully loaded. It's 160 and then divided by 8, the rate. And then how many miles it came back with the empty situation. Also same distance, but the different rate, it was 9.6. So then in this case, it's gonna approximately 37. Then this is the approximation that you can see the closest answer choice from the actual problem that you see from 5.5.